Hey YouTube, what's up? Got another episode here streaming the process of creating an e-paper ESP32 dev kit, and I'm going to do this in two parts today. This will probably drop as two episodes on YouTube this week. One, we have got our pre-run here that I'm going to talk about here in a second as soon as I turn this Twitch stream on, and just give you a general idea of how the layout's going. And then another video will be more about actually doing the layout. I don't know how interesting that's going to be for people. We'll see how it goes. But let me start the stream here. Just give it a second to start up and switch. Okay, so we're going to do two streams today. The first one is going to be this. So if you remember from last time, we did our pre-order. And I haven't even opened this yet, so we're going to do this right now. This is our OSHPark order, which, by the way, OSHPark, yeah, I decided it was OSHPark. OSHPark is amazing. The entire experience was awesome from uploading the file. I got emails throughout that said, hey, your board has been added to a panel. Your panel is headed to fab. We expect it to be back. It's just they... I don't want to say over communicate. It was just a perfect amount of communication to let you know, like, the process is moving. This is where your order is in the process. And then it showed up today. And so let's open it up. And if you remember from last time, the purpose of this was to see if we had created the board outline. So that's what you can see here on the screen. Which way is it? This way, right here. To see if the board outline, that yellow line, is the exact right dimensions to fit in our case. And so let's, oh man, it's got some nasty edges on it. Okay, well, those edges will not be on there when I get it from PCBWay, and I think it should give us a good enough idea. Little OSHPark sticker there. Okay, so here they are, 3 of them. And then if you recall, I put a couple of footprints on there just to see how things fit. And on the back side, you get the little battery there. I don't know how well you can see that. Ow, those things are sharp. Those little edges. Throw them in the trash can there. Okay, and so really, the whole purpose of this, I'm going to have to trim these off. Got an X-Acto knife here. Let's trim these. They are really sharp. Because we want to see if this fits in the case, and if it doesn't fit in the case, we'll make small adjustments and make it so that it does fit in the case. Just little fiberglass shavings everywhere now. This is probably a terrible idea. All right, well, let's just see if we can figure out if it fits or not. It would go in, actually I need the other side, front of the case. Right here, I'm gonna see if it fits in that. It would go in like this. It's perfect. Like, maybe slightly too perfect, like it's in there really tight. Like the cutouts, you're probably not gonna be able to see this on the camera, but there's 4 screw holes here, and the PCB curves around it. That's what, if you look on the drawing here, these right here, like these little cutouts go right where the screws come through the case, and it fits just right in there, like really nice and tight. We may be able to give ourselves just a little bit more leeway. I don't know. That's pretty good. I'm gonna say the back ones, and when I say the back ones, that's these ones over here. Those are the back ones. I'm calling the front where the USB connector goes. The back ones here are a little tighter than the front ones. But it's, yeah, I think we probably want to give it just a little bit more especially if somebody's going to 3D print. I don't know, it's pretty nice. Let me grab, stand by. I'm going to grab one of my 3D printed cases. Okay. Because these are not quite the same. And so if somebody 3D prints it, I still want it to be able to fit for them. That looks pretty good, actually, still. All right. I'm going to say that is pretty darn good. Of a fit. Just bear with me here. All right. We might need to make just a slight adjustment, but yeah, okay, so it's not fitting on the 3D printed one. Okay, so on my machine, this one is an actual injection mold, so it's very repeatable. A 3D printer is going to have not quite as high of a tolerance, and it does, yeah, it's not fitting on the 3D printed one. All right, well, I'll have to decide. I'm going to think about that. I don't know if I want to make it too much bigger because then it's going to wiggle around inside of my injection molded ones. So, cool. So I've got these in. That's cool. We'll decide if we want to make just a slight adjustment. I think everything else fits really nicely here in the case. Yeah, I mean, it fits in the injection molded one really nice. The other thing I wanted to do was test the footprint for, you're not gonna be able to see that, I don't know why I'm holding that up. It's a USB connector to see if the USB connector that I have fits into the footprint there, and it does perfectly. So that's great. So that actually looks pretty good. Yeah, that looks really good, actually. Okay, great. And then the other thing I ordered this week, which, where are they? I ordered an ESP32 to make sure that it fits on that footprint. I'm sure it will. Won't do that right now. But what we're going to do here, like I said, I'm going to split this into 2 streams. So that worked pretty well. I think we have enough information from the pre-run to maybe make a very slight adjustment. And I may even make an adjustment for, I may even make 2 outlines, like 2 revs, because that one fits really, really perfectly into my case that I ship like pucks in and things. And so I may just do a slightly bigger tolerance on those, on these. I don't know why I'm making symbols with my hands. Look, if you look on the screen here, just make these a little bit bigger so that it'll fit there. So great. And you know what else I forgot to do, just in case somebody shows up? Let's open up the stream manager on Twitch. Okay, great. All right, so let's talk about the board layout that we have so far. I did a first pass here, and I'm going to actually stream raw board layout. I don't know how boring or interesting that'll be, but just to show the process, I've spent about 2 hours on what you see here, aside from laying out the outline. And so this is everything. There's 2 resistors up here that I'm not worried about placing right at the moment. But so this is, like I said, about 2 hours worth of laying things out. And to help you, I had a little bit of a head start. I'll show you. I was using, let me drag it over here. This is the Gerber file, or not the Gerber file. It's a PDF of what the layout is of my existing board that I have. The front and back. This is the back, and this is the front. And what I did was I kind of used it as a key to like know where to place things. Like I put the USB thing obviously in the same place, but a lot of these components down here I put in the same place, and then a lot of this stuff's in the same place. The display over here is in the same place. So I kind of use that as a starting point. But actually, let me bring this back really quick. One thing that I don't like about this is down here. There's a button right here, and there's a button right here that were used. Those were the setup and reset button for the P1 module, and the placement of these was not good because the screen attaches right here, and so when it's in a case, I might be able to show this. When it's in a case like this, whoa, kind of clamshells like that, because the screen is glued in there. The buttons are way up here, and so you have to kind of like get your fingers way down into this part of it instead of them being out here. If they were out here by the USB slot, it would be much nicer, much easier to get access to them. And so not a great spot for the buttons. I found out, after the fact, as I was having to use those buttons to do a lot of things on the P1 module. I don't expect to have to use the buttons on the ESP32 version. In fact, I'm not even going to place them on production units that I use for some of our devices that we need, because there's no need for them. Customers would never see them, and so there's no need to even populate them. Although I am laying them out on the board. You'll see that in a second. The other thing is I'm still not sure about the placement of this thing down here, these big blue dots. That is the Tag Connect JTAG connector, and it's also kind of in a weird spot way down there, especially if it's already it's impossible. Once I've glued the screen into the case like this, it's impossible to connect it, just because of the angles and the ribbon cable and stuff. I would have to disconnect the ribbon cable, which it's very hard to get back in for the display, and so that's an inconvenient spot for that when everything's assembled. So I'm going to bring this back over here and show you some of the differences on our dev board. And so I'm going to use this as a production board as well as a dev board. I mean, we have a product that uses this exact thing. You can see it on that other one, the hockey puck. And so, but we're going to extend this to be an e-paper dev board like we talked about. And so you can see, maybe you can't see, because let me turn off that might help. The front silk screen, there we go. This right here is one switch, so it's right up next to the front by the USB port, and this is the other one right here. And so much more conveniently placed than it was before. Pull that back out. For now, I still have the JTAG down here because I don't know where else to put it. We might be able to make some room. So this was copying what I had before. And I've decided last night after working on this for a couple of hours that I don't want to lay it out the way it was before because of the subtraction of some components that I don't need for the P1 and the addition of some components that I need for the ESP32. So the P1 needed a bunch of external capacitors that had to be placed by certain pins on the P1 module. So the P1 module had a footprint that was very similar to this on the ESP32, but you had to have, I think it was 4 pair. So 8 total capacitors right next to sets of pins. There were some on the top, there were some on this side over here, and there were some on this side over here, which created some crowding over here with the display capacitors. All of these capacitors right here are just for the display, and it's best that they're over here on this side. And I don't have those on the ESP32. The only thing the ESP32 needs is these 2 capacitors right here, C14 and C13. And then C12 and R12 are part of the enable line, which we can talk about another time. But so those are needed as well. But they both go right over here on this side. And if you look, I'm going to drag it back over here one more time. On my old one, all down here is empty. This big yellow right here is just the white there in the bottom, your bottom right here, was just to be able to use a Sharpie to put like a designator on it. And so that was nice, but I don't really need that. And so I can use all of this space down here is available for components. And so what I've put down here for now is the FTDI chip. And so the P1 module, if you recall, supported USB out of the box. You come in, it's going to be really crowded in here. Let me turn this silk screen off again. These are diodes, capacitors, and resistors. All these components that you see right here. In fact, I can even, let's highlight them. Those are all for the USB. Those needed to be there for the P1 module. They need to be there for the ESP32 module. And so it's best if they're close to these. You can see let's come in a little bit more here. It's nice that all the nets are named. So you can see USB D-, that's data minus, USB D+. Those come straight off of the USB connector. So this DP, I'm going to draw a trace eventually that goes literally just to right there. So right nice and close, D- is going to go right there, and then it's going to go straight through here. D+ is going to go straight through here. And then it has to go through these two resistors. And then they can break off before this pad 1 here would go straight to the P1 module. This pad 1 here would go straight to the P1 module, and it would handle the USB. That is not the case anymore because the ESP32 does not handle USB out of the box. And so we need some sort of translation layer, what's known as a UART bridge, USB to UART, which turns those USB signals into just regular old transmit and receive lines, serial lines. And that's what this chip down here is. This is an FTDI chip that takes those in. And we'll turn the silk screen back on. Turns those into the transmit and receive signals. And so I was going to put that down here. However, let's turn the rat's nest back on really quick. It's going to get really noisy. The rat's nest, for those that have never done layout before, this shows you where everything needs to be connected. And so it'll say, for example, we zoom in, this pin right here needs to go to the enable pin. It's going to find the closest one, which is down here. Right down here. And that will help you when it's time to start drawing traces to know where you need to connect things. And then once the rat's nest completely disappears, you know that you're done routing your board. And so it can get really messy while you're trying to decide where you want to finalize the movement of parts, but it's extremely helpful when you're deciding where you want to lay them out. For example, let's come into here. This R14 needs to connect to MTCK here. And what we can do is we can grab it, flip it around. You can see that you want to try and get these, picture all of the white lines as wires and get them as close as possible to where they need to connect so that with as least crossing as possible. I don't know if you can kind of see it right here. Not a lot of these lines crossed. You can see it kind of creates this starburst type look right here. 1, 2, 3. Because we've oriented this in such a way that we can draw signal traces straight from, you know, this pad here into here. These all connect and then come over to ground. And so you use the rat's nest to figure out where to place components and how to orient them, flip them around. So like, as an example, again, I'm not sure if you can see that. Like, I know what I'm looking for. You might not know what I'm looking at. Again, these lines here, this sort of nice sunshine burst of non-crossing rat's nest lines, these white lines. Now, if I were to select this part and then rotate it, you see how they kind of all just cross and munge up? And then I do it again, and now it's even worse. And so I'm going to keep doing that until I get back to this nice position where everything's not crossed over so that we can draw straight trace lines. And so that's why the rat nest is very helpful when you're laying things out, so you know what needs to connect to what and where to place things. Now, what's really cool about most EDA things is that the rat's nest will dynamically redraw to show you what's closest. So you can see right here, C12 needs to be connected to ground. Eventually, we're going to do what's called a ground pour, and I'll show you that in a separate video, where everything that's not a trace is going to be a ground plane. And then the pins like this C12 ground right here, can connect straight to that pour instead of needing to draw a trace somewhere else. But right now, you can see it wants to go all the way over to this big ground pin right here, because that's the closest ground that it's near to. But if I wanted to move C12, say down here next to C13, it's going to redraw the rat's nest line as I do that. So let me just grab C12. Right here. So you can see ground, oh, it's already moved. Now it's down there on that C17. I'm going to keep moving it, and it's going to keep redrawing those lines. Now if I put C12 down here, it redrew both of them actually. So now the closest enable is right here instead of the enable pin on the ESP32, and the closest ground is over here. So that's where the rat's nest comes into play. You have to be a little careful because you might think, oh, well, this seems much better to have C12 down here because it can hit ground right here and it's right close to this enable. But the purpose of C12 is to debounce the enable pin on the ESP32. And so a rule of thumb for that is you want it as close to the enable pin as possible. So we want it to be over here by, you know, this enable pin right here. So don't always use the rat's nest as this is where you want to place it finally, because there's some subtle things like that you have to know about. And so I'm just Control Z and move that back up where it was. So I think that'll do it for right now. Like I said, I just wanted to show you what I've got so far. Oh, and I want to tell you about what we're going to change. So what we're going to do next time is I'm going to actually just stream me changing this layout, because what I found while I was doing this last night is that I think I can I'm going to have to slide the display components over all this stuff over here, because I've got the connector up close to the board edge here, but it's actually back from the board edge because of the way that the ribbon cable bends up and around. And so I actually need to slide this back, which means I'm gonna run out of room. It's gonna bang right into the ESP32 chip here. So I need to slide that over to the right, and I've got some componentry here that's you know in the way, so I have to move that. But all of this down here, the reason that the power circuitry, and I'm gonna turn off the paste again so that the silk screen, and I'm gonna turn off the rat's nest. So the reason that this was laid out the way it was before, and so when you're laying out, I don't want to say there's no wrong way and there's no right way. There's best practices for doing PCB layout. I don't know them all. I am not an expert on it at all, but there's some aesthetic things, like I really like that these capacitors are all perfectly lined up over here. They don't have to be. You could toggle them and make a zigzag if you thought that looked cool. Like there's some room for like artwork while you're doing PCB layout. One of the things Steve Jobs used to say was they wanted the hardware to look as beautiful on the inside as it did on the outside. And while it does make it easier to lay things out when everything is nice and neat, sometimes it's not. Like sometimes it looks, the uglier placement of things is easier to draw traces on. And so it's kind of a balance, like how do you want it to look, and then how at the end of the day you're just connecting all of these what are called nets together. Just you're connecting all the ground pads to a ground plane or to some source of ground, and you're connecting all the signal pins to wherever they go to. And it's just a matter of being able to draw that. You can't cross them, and so two wires can't cross each other, and so you have to do things like shoot to the other side of the board and draw and then come back up. And I'll show you some of that when we get to the actual trace drawing. I think we'll do that as a whole separate stream. But the reason that this stuff was put up here, so these two yellow pads are the JST battery connector, and they feed right into this chip right here, which is a charge management chip. This thing decides, am I going to use battery power or am I going to use power from the USB? So the USB also ends up connecting right up into this chip. And then this chip right here is responsible for deciding, I'm going to use battery power, I'm going to use USB power, and if I'm on USB power, I'm going to use that power to charge the lithium battery that's attached. That's what this does. And then it feeds over, it's got a bunch of capacitors around it and resistors. It feeds over into this chip right here. The purpose of this chip is it's a linear voltage regulator. It's going to take whatever voltage, whether it's the USB or the lithium ion, and it's going to regulate it to a fixed 3.3 volts. And so it's going to take whichever of those two sources the charge management chip decides on and turn it into 3.3 volts, which pops out here. And you can see that here. Now, if we zoom out, the reason this was all up here was because on the P1 module, the 3.3 volt was right here. That's how we had to power the P1 module. It was right here at the top. And so it made sense for this to be up here so that it could just come right down in here and connect to it. On the, sorry, did I say the ESP? On the P1 module. On the ESP32 module, however, 3.3 volts is way down here. And so if we left all of this the way we had it laid out for the P1 module, we're going to get 3.3 volts way up here. And now it's not like it's a big deal. We can just use what's called a via. It's a plated through hole that goes through the board to the back side. And then we could just draw the 3.3 volts down here, pop it back up underneath of the chip right here, connect over to 3.3 volts. That's one option. And we could do that. However, it would make more sense to me, at least, and this is what we're going to try to do in the next stream, is to move all of this component stuff down into this area down here. And so that when we're done going through all of that, we can just pop out 3.3 volts right down here where we need it, and then connect it right over into the ESP32 chip. Something of note here, you can see this keep out zone. Because of the PCB antenna, you don't want to have any copper or traces anywhere in this area. Even though the ESP32 comes straight here, we're not going to have any copper on our PCB over here or over here. We're not going to place any components there. We're not going to run any traces through there. So that's what that's for. And so the other reason that I want to move all that stuff down is because this right here is the FTDI chip. It's that chip, again, that takes the USB signals and turns it into serial transmit and receive signals. You'll see that the serial transmit and receive signals are way over here on the ESP32. They're over on this far left side of the chip. Sorry, right there. And so what I was thinking is to take this stuff, it's really kind of these components right here, take all of those and rotate them and put them up here, and then we'll be able to draw traces around, you know, maybe duck underneath here and come down. But it's probably 6s, but it's okay if we move this up to here. It would make more sense to have the power stuff down here so that we can connect it straight to the 3.3 volts. So that's what we're going to do. I haven't decided yet if we're going to move the JST plug here. It might make more sense to flip that and put it down on this side of the board instead. Anyway, that's what we're going to do. We're going to move all these things around. Once we have everything moved, we'll be ready to start doing our trace layout. So like actually drawing lines, getting rid of, again, this rat's nest. As you connect all these things, and I can probably show you that. Let me just see route tracks. So let's come in here and just do a sample one to show you what I mean. So I'm going to come right from here, and I'm going to connect it right to there, and the rat's nest line is gone. So it even labels the route there, and that's it. That one's done, and now it's rinse and repeat for every single one of these white lines on the PCB layout. So that's what we're going to be doing. The last thing that I want to point out that we're going to do is I want to have enough room, hopefully, to have 2 rows of header pins right here at the top. And the reason for that is because it's a dev kit. For those use cases that I want to, again, sell it as a dev kit, I want to have all the other pins of the ESP32 module broken out so that people aren't just limited to, oh, it's just for e-paper. They have the e-paper built into it, but then if they want, they can just put a right angle header right on this part of the board, pop it out of the side of the case, and connect jumper wires to it, and connect anything else they want to it, sensors or anything like that, using any of the other pins that are available on the ESP32. So that's the idea. That's what we're going to be doing next up when we try and move all this stuff around. And I'll show you kind of how the process of that is. Again, I don't know how interesting that'll be. I personally, I don't know if you know Louis Rossman. He has a channel where he fixes MacBooks. It's really kind of the same thing every time, but for whatever reason, I really enjoy it. It's soothing to watch him just work on that and talk through it. And so that's what I'm doing. I'm going to do that. Hopefully people find some interesting nuggets in there as we do that. But that's going to do it for this stream. This is where we're at. We may, again, make some adjustments. I'll think about that and let you know where we land on that. But for now, that's going to do it. I hope you found something interesting or learned something in here. And again, if you have any questions, feel free to hit me up in the chat or shoot me. I should get something to pop up here on the bottom of the stream. My email is kevin@sidwar.com. You can find me on Twitter at kevinsidwar and on Instagram at sidwarkd. DMs are open. Feel free to reach out and chat me up. I'd love to hear from you. So thanks, and we'll see you again a little bit later.